practicing transformation. So the examples that we've been given, we're asked to provide that we're provided with an empty XY table and a graph of the parent function. We need to fill in the table, graph the quadratic on the same graph as the parent function, and then describe the changes or the transformations between the parent function and the given function. So first off, on every graph here, you see that the parent function x squared has already been graphed so that we can very easily see the difference between the two. So you may want to grab a different color to draw these pictures in. These graphs, maybe a colored pencil or something might just kind of help you see that a little bit easier, but you can most definitely do it in pencil if you would like to. So we're going to start off with, here we have our equation. It's in vertex form just because it's easiest. We know that if we have it in standard form, we can still find that vertex. We can still find that axis of symmetry. We've practiced that. We know how to do it. So we can still find those values if we need them. So for now, it is in vertex form, so we know that the vertex here is going to be at the point -2, 6, because our h value here is a -2, our k value is 6. That's going to be my values that go here in the middle of my xy table, and then of course I'm just going to use my calculator to plug in the rest of those values, but we know that what we can always do is if we need to do it by hand, we can take each of these x values that we want. We know we want a -3, a -4, a -1, and a 0. Take those x values, plug it in here, simplify, and find the y value. But just for time's sake, I'm going to go ahead and plug it into my calculator and let it do a little bit of the work for me. So at -4, we have a y value of 10. At -3, we have a y value of 7. Of course, -2 is 6, -1 is also 7, and 0 is 10. So those are my points that I'm going to plot in order to graph my my parabola here. So one thing that as we get ready to graph this, we want to look out for, we know that our a value is 1. So it's going to be a +1. It's going to have the same scale. It's not been flipped. It's going to be going in the same direction. It looks like our vertex tells us that we've moved left 2 and up 6. So hopefully that's where we end up with the same direction and everything else from there. So we're going to give this a shot. We're going to go ahead and graph each of these. So -4, 10, -3, 7, -2, 6, -1, 7, and 0, 10 makes for a graph that looks like this. And it's exactly what it is. It has moved left 2 units and up 6 units is the direction that has changed. And that's what we gathered from the information that we had from our equation. But seeing it graphed, you can see that very easily. It's moved left 2, up 6, and it's still in that same scale. It's still in the same direction, opening upwards. So we're going to continue practicing. We're going to do this again with number 2, same process. On number 2, we notice that the vertex is 3, 4 this time. So in theory, we know that this is going to be moving to the right 3 and up 4. We still have the same scale. It's still a positive number, so really we should only be moving left and right on this one. So we have a 3, 4 here as our point. We're going to plug that in to make our changes. So x minus 3 squared plus 4. We're going to get our table values, and I'm going to plug those in. So we know we need 1, 2, 3, 4, and 5 for our x values. So 1 is 8, 2 is 5, 3 is 4, 4 is 5, and 5 is 8. So I'm going to go ahead and plot those points. I end up with 1, 8, 2, 5, 3, 4, 4, 5, and 5, 8. And so there are our points right there. And just like we thought, it's the same scale, the same direction. It's just been moved right 3 and up 4. All right, another example. This one's a little bit different, so let's see what happens on this one. First off, we have a vertex of -6, -3 on this one. So I'm going to plug those values in. I'm going to want -7 and -8, -5 and -4. I'm going to go ahead and plug this in to my calculator, just like we've done before in previous videos. I'm going to pull up that table. All right, and I end up with -8, -7, -7, -4, -6, -3, -5, -4, and -4, -7. So we're going to go ahead and plot those points as well. So -8, -7, -7, -4, -6, -3, -5, -4, and -4, -7. And that's going to show our graph. Now on this one, we notice that it has been reflected over the x-axis. It's flipped upside down. Ooh, let's see. There we go. Trying to write two words at once and my brain went too fast. So reflected over the x-axis, that's one transformation that's made. And then it's been moved left 6 and down 3. So it's moved or shifted or transformed, moved left 6 and down 3. All right, number 4, let's go ahead and look at this one as well. So on this one, we had a value of 1/4. So we'll see what happens on this when we graph it. So our vertex here, we have a 7, and then there's no number out here. So we know that that's going to have a 0 for our y value. So I'm going to plug in 7, 0 in the middle. I'm going to go up to 8 and 9, and I'm going to come down to 6 and 5 here. So I'm going to plug this in into my calculator. Takes me just a minute to plug it in this time since I have that 1/4 value. Let's see. There we go. And then let's get rid of it. All right, so 1/4 times x minus 7 squared. And here we go. Oops, I went the wrong direction on my table. Gotta catch me on things like this. All right, so 7, 8, 9, and then back up this way. I'm used to doing negatives that I forgot which direction I should go. So there we go, 5, 6, 7, 8, 9. All right, so on 5, my y value is 1. At 6, my y value is actually 0.25. 7 is 0, 8 is 0.25, and 9 is 1. So when I go to graph this, we're going to do 5, 1, 2, 3, 4, 5, 1. We're going to do 6.25. So I'm going to put a point kind of a quarter of the way between those two. I'm not going to be exactly precise just because it's a little bit difficult to see that. 7, 0, 8 at 0.25, and 9 again at 1. And so my parabola is going to be very wide and look something like this. So transformations, we notice that it's moved to the right 7. It didn't go up and down any direction, but it did move to the right 7. That's where we get from that h value of 7. But then it's also much wider. So what we've done is taken that graph and compressed it or pushed it down and made it very wide with that 1/4 scale value. That's kind of what that looks like. And so this has been vertically compressed. Okay. All right, and the last example, let's go through this one as well. So we have y is equal to -2x squared minus 2. So in this one we have a vertex here, and this one's a little bit different because it's in standard form, but it's kind of also in vertex form, because if I took this and put parentheses around my x, it's now in vertex form. We can't always do that, but on this one example, it does work either way. So what I notice is there's no value inside of the parentheses. So my x here for my vertex is going to be a 0. My h value is a 0. And my y value is that -2. And then I have that a value of -2. So 0, -2 is going to be my vertex on this one. So I'm going to go ahead and plug in my equation into my calculator. X squared minus 2 and graph that. All right, and then I'm going to go -2, -10, -1, -4, 0, -2, 1, -4, and 2, -10. So without even graphing it, things that I notice, it looks like there's no horizontal shift, but it is going to go down 2 units. I notice it's a negative value, so it's going to be flipped upside down, and I also notice that it's a 2 instead of a 1, so the scale factor is going to be stretched this direction. So let's see what happens when we graph this. So when we graph it, we have -2, -10, -1, -4, 0, -2, 1, -4, and 2, -10, and that makes for this right here. And it's exactly like what we thought, although it's a little bit tricky to see that scale. It has moved down 2. It has reflected over the x-axis, has flipped upside down, and it has been vertically stretched. So here it was that compression, that smaller scale. This one has that larger number, the 2, and so it's kind of stretched it back out a little bit. So just a couple of differences and things that I wanted you to be able to see as we work through transformations.